Hi everyone and welcome. In today's lesson we'll be looking at Theorem 3 and here's what it means. When an angle is on the circumference of a circle and it is subtended by the diameter of the circle, then the angle will be equal to 90 degrees. Now let's have a look. Now here we have angle C, which is on the circumference of the circle, and it is subtended by this diameter AB. Now when an angle is subtended by the diameter, it means that this angle on the circumference will be 90 degrees. Now let's go and prove it. Now we are given circle O with O the midpoint of the circle. AB is the diameter of the circle with C on the circumference. Now we want to prove that angle C is equal to 90 degrees. And here's our proof. So we'll start our proof by looking at this point or angle on the diameter, which is at the center of the circle. We're going to call this angle AOB. So angle AOB is equal to 180 degrees because it's an angle on a straight line and the straight line's name is AB. Therefore, we have the angle at the center, so that means the angle at the center is 2 times the angle on the circumference of the circle if it's subtended by the same arc or chord. In other words, angle C is equal to 90 because the angle at the center is equal to 2 times the angle at the circumference. Now, we are not going to use this reason when we have Theorem 3. In other words, when we have an angle on the circumference of the circle which is subtended by the diameter, we are going to use this abbreviation, angle in semicircle, to prove that this angle is 90. Now let's go and look at an example. Now here we have the following diagram, and they give us the following as well. E is the center of the circle with ABC on the circumference, AC is parallel to DE, and angle DEB is equal to 55 degrees. We want to show that AD is equal to DB, and we want to calculate angle B. Now let's quickly look at what all of this means. Here we have E at the center, so which means that this line that starts from C all the way through the center to B is the diameter of the circle. They also give us this angle which is DEB, and it's 55 degrees. They also tell us that DE is parallel to AC. Now please remember, when we have parallel lines, it means that there might be alternate angles, there might be corresponding angles, and there might be co-interior angles that exist. Okay, so don't forget about it. And now we want to show that AD is equal to DB, and we also want to calculate angle B. Now here we go. We cannot simply say that this line that starts at the center is perpendicular or bisects this chord because we have no information. There's no 90 and it doesn't show that we have bisected this chord. That's actually what we want to prove. So we must show that these angles are 90 with some other way. Now we know that this is an angle on the circumference and it is subtended by the diameter. In other words, angle A will be 90. So angle A is equal to 90 degrees, and what is our reason that we just learned? Angle in semicircle. There we go. So now we know angle A is 90. That means that angle EDB will also be 90 because these two angles are corresponding angles because these two lines are parallel. So I write angle EDB is equal to 90 degrees. Corresponding angles are equal, and don't forget, when we have corresponding angles, we have to indicate which lines are parallel because AC is parallel to DE. That means that AD is equal to DB because this is a line from the center that is perpendicular on this chord, and it means it bisects the chord, right? So AD is equal to DB because line from center perpendicular to chord. And now it's easy to calculate angle B because we have two of the three angles, so we can simply say that angle B is equal to 180 degrees minus 55 degrees minus 90 degrees because of the interior angles of triangle DEB, which is this triangle, and we can say angle B is equal to 35 degrees. And we are done. See you again next time. Bye.